Okay, here we've got a connected particles question from the June 2010 M1 paper. Okay, we have a classic pulley problem. We have masses 12 and 8. We have a light, inextensible string. Strings are always light and inextensible, going over a smooth fixed peg. Okay, pegs and pulleys are always smooth. Okay, so we've got to release them from rest. They move vertically, no air resistance, so everything's normal. And we've got to form two equations of motion. Now, when they say equation of motion, they mean F equals ma. So we need to, in other words, we need to do what we knew we were going to do. We're going to do F equals ma for A and for B. Now, we can't do F equals ma until we've got forces, because F is the resultant force. So we need to do separate force diagrams for A and B. But we can do them on here. So for A, it's 12 kilograms. So there's a force of 12g, weight is mg, 12g downwards, and there's a tension acting upwards. And similarly for B, we've got an 8g downwards, and there's a tension acting upwards, which I'm also going to call T, because the string is light and inextensible, and because the pulley is smooth, those two tensions are the same. Okay, but the other thing I need to put on my diagram, although it's not a force, is the acceleration, because I've got to get my signs consistent. So I need to say here, clearly this has got more mass, so this one will accelerate down. So my acceleration on this side will be downwards, and my acceleration on this side will be upwards. So when I do F equals ma, those arrows are going to tell me the positive direction. So let's do it. So for A, acceleration is down, so the resultant downward force is going to be 12g, which acts down, and the T acts up, so it's 12g minus T, which equals ma. The mass is 12, so that's 12a. And for B, we've got something similar, except this is accelerating upwards, so I take up to be positive. So now it's the T that's positive, so it's T minus 8g. 8g is the downward one, equals mass times acceleration, 8a. And what have I done? I've formed two equations of motions, and I've got to show that, so I've got to be convincing, I've got to get to an acceleration of 1.96. Okay, so we want the acceleration, so we're going to eliminate t, and if you set these equations up the way that we've discussed, then you always get a plus t in one and a minus t in the other, so we just add them. So 12g minus 8g gives me 4g equals 12a plus 8a is 20 times a. So to find the acceleration, a equals 4g divided by 20. 4 times 9.8 over 20. And if you do that, your calculator gives you exactly 1.96. Okay, and it is exactly that value, so that's the best we can do. If this was a rounded value, then you'd want to show the unrounded value and then round it off. That's how to be convincing. But here you get exactly 1.96. And of course, it's meters second to the minus 2. All right, though you may not get penalized for not having the units. Then we've got to part B, find the tension in the string. Okay, so that's the other part of solving these simultaneous equations. Now I know that A is 4g over 20, or that 20a is 4g. I just substitute that into one of these equations. So if we put it into the second equation, okay, T minus 8g equals 8 times 4g over 20. So that is that's 32g over 20, which cancels down to 8g over 5. Okay, so this implies that T equals 8g plus 8g over 5, which is, well, you might as well just put g equals 9.8 and put it in your calculator. You get 94.08, which you can round to 94.1 if you want to. Okay, and the units of that are newtons. Then we've got to say, oh, they've been moving for 2 seconds. We're dealing with this height, and the strings are in this position, the string breaks, and we've got to find the speed of the particle. So now we're relating things like distances and speeds and times, and we've worked out an acceleration, so we're doing SUVAT. Okay, so I've got an initial speed here, I've got a time here, I've got an acceleration, okay? So it looks like this 4 meters, that doesn't come in just yet. I'm going to do SUVAT with those things. So SUVAT starts from rest, U is 0, time is 2 seconds, acceleration is 1.96, okay? So I'm taking down as being the positive direction, okay? So I want to find out its speed when the string breaks. Well, that's at time 2 seconds, so I want to find v. So v equals u plus at. U is 0, so that just equals the 1.96 times the 2, which is going to be 3.92, and it's meters per second. Double underline that, so that's my answer to part C1. Of course, I'm being very naughty in writing the answers on the question itself. Really, these ought to be separately written out very clearly. Okay, so that's why my answers are all horrible and squashed up. Don't imitate me. Okay, now in the next part, I've got to find the speed of particle A when it hits the surface. Okay, all right, so that means I am going to be using this 4 meters. I am going to be doing suvat again. What I need to remember is that, okay, when it's traveling at this speed, so immediately after it's traveled, done what it did in part 1 here, the string is then breaking. So the acceleration from this point onwards won't be 1.96 anymore. It'll now be 9.8. So I've got a distance of 4 meters. I've got an acceleration of 9.8. And I'm starting this phase of the motion. Okay, this 4 meters applies when the string breaks, and its speed when the string breaks is this 3.92 I've found. So that was my v, but now it's going to be my u. It's the initial speed for the next phase of the motion. So here is my s, u, and a. That's a question mark next to v. So it's traveling 4 meters. It started at 3.92 meters per second. I'm going to find its final speed, question mark, and then its acceleration is g, and these are both downwards, so my signs are consistent. Now, if you have not learned all the suvat equations, it's possible to do this using s equals ut plus half at squared, solving a quadratic to find t, and then going back to find v. But ideally, you've learned that v squared equals u squared plus 2as, and if I substitute in my values of u and a and s, 3.92 squared plus 2 times 4, 2 times 9.8 times 4. Okay, and if you do all of that and then square root it, then you get this answer of v equals 9.68 meters per second. Okay, and then that takes us on to the last part. Okay, now we're thinking about particle B. Okay, and how long it's going to take B to reach the surface after the string breaks. Okay, so what will be happening to B? Well, we've been considering A all the time. When the string broke, we worked out that A was travelling downwards at a speed of 3.92 meters per second. But B is attached to the other end of the string, and up to the point the string breaks, then what B does is exactly what A does, but in the opposite direction. So B is travelling upwards at 3.92. So we are now considering, that's not an acceleration, it's a speed. It shouldn't be double. These shouldn't be double arrows. What a load of rubbish. Okay, it's moving upwards with a speed of 3.92, and then the string breaks. So I can forget about A, and as with A, after the string breaks, it's just an acceleration of 9.8 downwards. So now we've got a suvat. Now, if I take up to be positive, because that's the way it's moving, I have to take the 9.8, the acceleration, to be 9.8 downwards is minus 9.8. So I've got a suvat, I've got the initial speed of B, I've got the acceleration of B, okay, and I go back here, and that 4 meters, both particles are at a height of 4 meters above the surface. So I can use S equals 4 meters for B as well as for A, because by coincidence they were both 4 meters above the surface. So I'm going to set up that suvat. So we've discussed the U is 3.92 up, the acceleration is minus 9.8 because it's down, and S is also started out that B was above the surface and lands on the surface, so S is also downwards, so S is minus 4. Okay, if you've taken down to be positive, then you just get all of those three things with the opposite signs, but you must have the correct signs on them. Okay, this time I want to find T, so I am using S equals UT plus half a T squared, and I'm lobbing in my S, which is minus 4, equals my U, which is 3.92, times T plus a half A, which is minus 4.9, okay, T squared. So the equation I want to solve is 4.9 T squared minus 3.92t minus 4 equals 0. And I can use my cheating quadratic equation solver on my white calculator to do that. And my calculator tells me that t equals 1.39 or minus 0.588. Okay, but of course I need to select the one I want, and I'm not interested in the negative time. That can't apply. So it is a 1.39 seconds is my time t, and I am done.